Assalamu alaikum wa rahmatullahi wa barakatuh. Now we give a presentation about our project. The titled Noise Measurement and Analysis, presented by Habib Abdelmassin Habib Al Jabbar and Muhammad Saad Qasim. Introduction. Noise is a pervasive element that affects well-being and productivity in daily life. Extensive research is being conducted globally to understand and address the impact of noise in indoor and outdoor settings. Construction industry, particularly in academic and industrial settings, focuses on material and article that minimize and isolate noise. The study examines the AST building at the UKM to analyze noise levels and create a favorable work environment. Experiment analysis identify sources of noise and highlight areas for mitigation strategy to improve the building design and function. The report explores theoretical concepts, measurement model, and particular techniques for mitigation noise in the AST building and the future project. Project motivation. Noise is a global issue impacting both indoor and urban environment. Categorized by the World Health Organization (WHO) is a major health concern. Over 1.6 billion people worldwide are exposed to excessive noise, leading to health impairment, sleep disorders, issue, and poor cognitive performance. Noise has become a growing concern in educational institutions, affecting productivity, communication, and focus. The study focuses on a newly constructed building to investigate noise perceived, analyze its impact, and propose mitigation technique, understand noise and employing measurement and analysis technique in the building with the enhanced productivity on local and global scales. Objectives. The project has three key objectives: to conduct experimentation to record ambient noise in the AST building across various locations. Number two, the development MATLAB model for analysis the recorded noises and making inference. Finally, to develop the dashboards on things central for the display of experimentation outcomes. Noise characterizations. Noise is a type of mechanical wave characterized by variation in pressure as it travels through a medium. Noise exhibits random patterns and lacks regular propagations patterns. Noise characteristics include intensity, which quantifies the amount of sound energy in decibels. Can calculated by the equation. Frequency refers to the bits on tonal quantity of noise and is measured in hertz. The duration of noise determined is long-term and short-term effect on human health. Noise can be classified based on its spectral content, which represented energy distribution across different frequencies. Temporal variation in noise-related fluctuation and steady-state characteristics impacting perceptions and annoyance levels. Noise can be impulsive, characterized by a rapid rise in decibels level for short durations. Impulsive noise can mostly occur in industrial setting during operation like hammering and slamming. Impulsive noises are associated with peak sound pressure level and maximum sound pressure level. Analysis techniques. Discrete Fourier transform (DFT). DFT is widely used technique that efficiently analyzes the frequency distribution of a noise signal, decomposing it into frequency component and reducing computation complexity, enabling easier processing of large signal. Mathematically, DFT is computed using the following equation. Here, xk represented the complex frequency spectrum, and xn is the discrete time domain signal and the total number of samples. Spectral flatness. Spectral flatness, also called spectral bandwidth ratio, is an entropy measure that characterizes the shape of a frequency spectrum by examining the distribution of energy across multiple frequency components, calculated as the ratio between geometric mean and arithmetic mean of power spectral density (PSD) of a frame. It can be calculated spectral flatness by following equation, where n is the number of frequency bands over the frequency range.
Assalamu alaikum. I'm Muhammad Saad Qasim. I will complete my parts of presentation. So let me start with the methodology. The experimentation consists of two phases: recording ambient noise levels using microphones placed in different locations inside two rooms, transmitted via an IoT network to the cloud, resulting in 8 sounds file. So the analysis phase involves the development of the algorithm that provide insights into the time and frequency properties of the signals. Then overall approach of the study is depicted by a block diagram illustrating in the top methodology on next slide. As you can see here, we have 4 locations to record the sound of noise in 2 rooms and make analysis for this sound in MATLAB and transition this data analysis in Think Central. Result and analysis. Recorded audio signal. The recorded audio files have been analyzed for the amplitude versus time axis. The sampling frequency of 84 kilohertz with an average duration of 6.5 seconds, and then sample recorded signal, as you can see here, in the top for room 1 and in the bottom in the room 2. Noise level. The table as shown below summarizes the noise level recording across both rooms. The result noise level in room 1 is lower than the average noise level in room 2. Zero crossing rate. As you can see here in figure as shown, the zero crossing rate, it has been found that the noise exhibit a high degree of randomness across all the settings. Minor change may be observed over time. Spectral flatness. By finding the spectral flatness as shown in figure, it has been analyzed that the entropy contained in the frequency spectrum of the signal is high. This determines that the nature of noise and has demonstrated an absence of impulse of deterministic noise. Project dashboard. As you can see here, we have the design of project dashboard and all the transition from MATLAB to the Think Central. Noise mitigation proposal. Introduce soundproofing and isolation materials such as acoustic panels and isolation foams. Install vibration isolation materials to minimize the impact of the external sources. Implement a properly designed ductwork isolation to prevent air distribution system from generating noise. Applied active noise cancellation system in specific area. Optimize room layout and equipment placement. Conclusion. The study analyzed the sound characteristic in the AST building of UKM University by recording and analyzing sound data using MATLAB. Features such as noise level, DFT, STFT, PSD, and spectral flatness were examined. Room 2 exhibited higher noise level compared to the Room 1, but fundamental characteristics were similar. Suggestions were provided to mitigate the impact of noise based on these parameters. Here we are recording the sound of noise from different locations. Thank you for your attention.